Okay. Okay. So how do we do these kind of things? We've got a contest fast food restaurant offered the following cash prizes, probabilities of winning, when a customer buys an order of French fries, $1.35. Find the expected winnings if the player buys 14 orders of French fries in multiple visits. Okay. Find what are the expected winnings? Okay. So you get $100,000, and the probability is 1 out of 8.5 million, basically. 50,000, right? You see the connection? See what they're saying up there? Probabilities of the various things. So you get $100,000, but there's a 1 in 8.5 million chance, and you can win $50,000, 1 in 302,000, $10,000 prize, $1,000 prize, $100 prize, $25 prize, 1 in 10,000 chance, basically, of getting a $25 prize. So, yeah, so now you can actually calculate the probabilities of these things. You can figure out what you should really expect on average, what the value of these things is. Does that make sense? This is how you actually calculate all random things. Okay, so let's do this. Remember I suggested that you set the cost aside? Let's set the cost aside. We'll subtract the $1.35 cost at the end of the problem. Does that sound good? We'll subtract the $1.35 cost at the end of the problem. And let's just do the winnings right now. So how do you do the winnings? The expected winnings equal, remember what it is? It's value times probability. Value times probability. Value times probability, Just multiply. It's just value probability. Value probability. Just multiply and add them all up. So I just got to take $100,000 times that. So it's going to be, right, you win $100,000, but the probability is 1 over 8,504,860. Plus the next value, 50,000 times the probability, 1 over 302,500 plus Does that make sense? All the way down to the last one, $25 times 1 over 9,540. Get the idea? Can we do that real quick on your graphing calculators? Right? So basically just multiply the prize times probability. Prize times probability. Just add them all up. So let's do that. And you know what you can do to make life easy for yourself? Is you can just put the 100,000 over the 8 million, right? The 1 on the top doesn't matter, right? When you multiply 100,000 times 1 over 8.5 million, that, just to make it easier to type in, that's 100,000 over 1. So these guys multiply on the top, these guys multiply on the bottom. So really it's just going to be 100,000 over the 8 million whatever number, right? Added to the other one. So just put the prize over the probability plus the prize, because multiplying by something in the denominator is dividing, really, isn't it? So might make it easier. There's a lot of zeros here. Plus, so be careful. Let's see, 10,000. Let's see if you can do it without messing up. Let's see if I can do it without messing up. Okay, here's what I'm getting. I hope I didn't hit anything wrong. I'm getting 0.2225. They probably want me to round near a cent, yeah. So that'd be 0.22, 22 cents, in other words. Did y'all get that? So what is that? What, like if somebody's asked you real life, what is that number? 22 cents. What's 22 cents? Yeah. In other words, all these different prizes, really, on average, you're winning 22 cents. Now, the truth is, you can't win 20 cents. You're either going to win $100,000 or $50,000 or one of those prizes, or nothing. But the average is going to be 22 cents. That's what that ticket's really worth. Does that make sense? That's the average ticket value among all the tickets. That's what that ticket is really worth on average, 22 cents. So now they're saying, but every time you buy the ticket, you have to spend how much to get the ticket? $1.35. So really, we've got to take 22 cents, but subtract $1.35. Right? Because that's the cost. Remember, you subtract the $1.35 at the end. If you subtract those, what do you get? Minus 1.13, minus $1.13. So in other words, you can expect to lose $1.13 every time you pay for the French fries. You get your little ticket, which has average value of 22 cents. So really, you just lost $1.13. You get the fries, I guess. But if you're really trying to do this for your bank account, know that you probably, on average, just lost $1.13. That's what really happened to your bank account. Does that make sense? Because the value of that ticket is only 22 cents on average. That's what expected value means. I know that seems weird because you think, well, what do you mean 22 cents? Well, right, I know you can't win 22 cents, but I'm saying that's the average. So that's the average. That's what the casino, for example, or the lottery people know. So that's what the average ticket is really worth. Subtract $1.35, you're really losing $1.13. And how many times are we doing this? 14 times. So if you do this 14 times, what can you expect to happen to your bank account? 14 times $1.13 loss. I'm getting $15.82. $15.82. We can expect to lose $15.82. We'll get our fries. We'll get our 14 orders of fries. We might win a prize. We might not. On average, $15.82. Let me go back again. So is that good then? Does that make sense what we did? So one more time, you do expected winnings. It's just value times probability. Value times probability. Add them all up, get 22 cents. And then you've got to subtract the cost at the end. Whatever it costs to play the game, to buy the ticket. $1.35, you subtract that. You get $1.13 is what you're going to lose on average every time you buy fries. You're paying $1.35 for the fries. You're getting 22 cents back in ticket value. You lost $1.13. You do that 14 times, multiply by 14, you lost $15.82. That's what you should expect to happen to your bank account on average. You know who, what other, not just casino industry, you know who else lives and dies by this calculation? The other, well, I guess the only legalized gambling industry in the whole United States?
Stock market. Lottery.
Well, I guess, yeah, I mean, that's true. Lotteries. Yeah, I consider lottery just like this. But insurance. That's what insurance is. You ever think about it? My dad used to always say, life insurance. I'm not going to buy that. You're betting you're going to die. Well, but that's a pretty good bet, though. Yeah. So anyway, but that's what you're doing with all kinds of car insurance, life insurance, all kinds of health insurance, right? You're betting. If you knew you're going to have perfect health, never need to go to the doctor. Well, who needs health insurance, right? If you're never going to have a car accident, well, it's the law. You have to have car insurance. But if they didn't make it the law, and you decide I'm just going to risk it, I'm just going to, I'm a perfect driver. Well. Right, so you notice that really all insurances are a bet, aren't they? And there's a chance that you'll need them, but you're going to pay. Well, my point is this is exactly what insurance companies do, is they calculate the exact same thing casinos calculate. Expected value, this. They say we're going to sell 10,000 policies. Well, they figure out their tables. You know, they know how many they're going to have to pay out for $100,000 policies, and you know, for the various kind of, like, you buy fire insurance for your house or whatever. They know the number of policies they pay out on average, what they're worth, what the policy. That's how they decide what to charge, so that they make on average profit per policy. That's how they decide that. In fact, the people that do that, it's one thing. If you really wanted to go into math, you'd have to be really serious and really good about it. They're actuarials. They're the ones who often become, usually they're the vice presidents in insurance companies, are actuarials. It's a branch of mathematics. It's a whole profession. And their job is to calculate these kind of things. I mean, much harder than this. Probabilities, like if there's a tornado in this area, what's the chance? What's the average amount of damage it will cost? And then they help insurance companies decide where they should set their policies. It's all based on math. What it's going to cost, what the probability is, how many policies there's going to be, so that the insurance company still makes money on average, even though they pay out a few big claims. It's all legalized gambling. That's what insurance really is. So, probability distributions, expected value. Survey asks respondents how many days they had eaten food prepared at a restaurant in the previous week. Probability distribution given below, find expected value. Okay. So first off, is this table speaking to you? Before we get into the da-da-da, what is this 0.22 being below the 2 there? What does that even mean? Give me real life. Let's make sure this is real for you. What does that mean in the real world? That 2 and the 0.22. What? You understand what these words are saying, what that table means? It's not real. I learned a long time ago that the more real the math or the science was to me, the better I would know what to do. Don't try not to just blindly use formulas. That doesn't work out too well. It's not real for you. What does that mean in the real world? 0.22. What? My old physics teacher used to say, 2 dogs in the kennel, Heron? What is that? 2 dogs? What is that 2?
Maybe days.
Days what? How many days until Christmas? Days what? Days that we ate at a restaurant. Exactly. Respondents, how many days they had eaten food prepared at a restaurant. Right? Survey in the previous week. So this last week, how many days did you eat restaurant food out? My desire is always to make that number as close to 0 as possible. And my wife and kids' desire is to make that number as close to 7 as possible. And so there's always this underlying conflict. And they would say I'm cheap, but I think they don't understand the economics of 5 children on 1 income. But anyway, so how many days in this last week did you eat out? So next Friday we're going to take my daughter out for her birthday. And she's, I wanted to make food. I'm like, I can make steaks at home. I can barbecue. Lizzie's nice about it, but I was talking to my oldest son, Dan. He's like, Lizzie would really like to go. I'm like, all right, we'll go to BJ's. We'll go. That's where she wants to go. I'll spring for an out meal once in a while. All right, anyway, I'm telling you, going on and on about my little deal. So that 2 is the number of times out in the last week. And what's the 0.22? It's the chance, probability, right? Or it's like 22% of the people ate out 2 days last week. 12% of the people ate out 3 days last week. 10% of the people ate out 4 days last week. 9% of the people ate out 5 days last week, etc., etc. Makes sense? The most, if you ate out all 7 days last week, 3% of the people ate out all 7 days last week. It's not healthy either. Anyway, I'll stay off that topic. All right. Okay. It's expensive and unhealthy. All right. But I guess it can be fun. So there we go. Now, what do they want? They want expected value, meaning what is the average for this crowd, this survey, this crowd, what is the average number of days people ate out last week? Well, how do you do average? Average is expected value. I don't know if I've said that clear up to now. Expected value is average. So if you wanted to say, what's the average, like how many days do people eat out in a week? At least this crowd that was surveyed. How many days on average? I mean, do they on average eat out 2 days, 1 day, 3 days? What is it? Well, you would just do the expected value, which is what? Multiply, 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 add them up. Right? The value here, instead of money, is number of days eating out. Does that make sense? So I'll take 0 times 0.11 plus 1 times 0.21, right? See where I'm coming up with these? Plus 2 times 0.22 plus 3 times 0.12 plus 4 times 0.10 plus 5 times 0.09 plus 6 times 0.12 plus 7 times 0.03. Good? Just add them up on your calculator. You don't need to do the 0 one, huh? That's going to be 0. Just skip that one. I'm getting 2.79. Did y'all get that? So the average number of days out, 2.79. So among this crowd, on average, they ate out 2.79 days last week. So all good? Just another expected value calculation. It's a probabilistic average. That's what it is. On average, 2.79 days eaten out for this crowd last week. Any questions on that? So expected value calculation is very, very versatile. It works in. Did your heart leap when you saw it? Yes. Now I have something to do this weekend. No, maybe not.
Wait, our final's Thursday, right?
Yeah, when is our final?
We're filming
Excuse me. Excuse me again. Yeah, our final is Thursday. Yeah, 2 weeks from today, 17th. And next week's normal class week. The final is due not this Sunday night, but the following, like the end of next week, right before finals week starts, Sunday at midnight. So it's like the last end of the thing, so you can just prepare for the final. And I'll go over it next Thursday. I'll just devote the whole time to going over it.
Final?
The practice final. Actually, the final, the practice final.
It's due next Sunday.
Yeah, not this Sunday, but Sunday the 13th, right before finals week starts.
And then you're going to go over it next week.
Yeah, I'm going to go over it on Thursday. I might not get through the whole thing. Yeah, I have 37 questions. I might get through 2/3 of it, something like that. Yep. All right. Determine whether the probability distribution is valid or not. What do they mean, valid or not? I don't know. These questions are always weird.
Didn't you have to add all the bottom ones up?
Yeah, they have to add to 1. Probabilities have to have to 1. We know that, right? I couldn't say 80% chance of rain, 30% chance it won't rain. Well, that just doesn't work, right? So they have to add up to 1. I think they do, though, right?
Yeah.
0.25, 0.25, 0.25, 0.25. That's 4 quarters, $1. That's good. I think this one's fine, isn't it? I'm asking you. I think it's good. I don't like these. These are dumb. No. A probability cannot equal 0. Yeah, it can. They do some to 1. Yeah, that's all good. And that's a problem. These will be quick. Honestly, I'm not going to put these on your final. These are dumb questions. The distribution is about, I don't know, add them up. What do they add up to be? Oh, this is you can't have negative. Yeah, that's wacko. Right, what's the chance of rain tomorrow? Negative 10%. What does that even mean? Right? No, you can't do that. Probability cannot be negative. That's wacko. All right, so that's a dumb one. We'll just invalid, negative. Yeah, add them all up, subtract from 1. These are cake. So call this one X or whatever. Add them up, 0.02. 0.12. You don't have to put an X. Just add them up. 0.01. What is that? 14, 38. I don't know. I can't do that. 39. 8.84. And then 1. And then take away from 1. 0.16. So this guy must be 0.16. I think, did I do that right? I did it quick. Is it good? All right. There we go. So just add them up and subtract from 1, huh? Because they got to make 1. All the probabilities have to, like, rain and not rain. If there's 80% chance of rain, then it's 20% it won't rain. They have to add up to 1. A distribution means all the things that can happen. A probability distribution. Because they're listing when they do that, they're saying this is everything possible. So they've got to make 1.